All right, I want to talk about a particular counting trick that we have to use. And to do that, I'm actually going to start with an example. This is one of those things where knowing why you do something, we invent a weird math, helps us deal with having to use that weird math. So I'm going to have an RBG set of colors. And we can imagine, these balls being in a bucket, and there are different colors, and I'm going to pick them out. And I want to know what combinations I can get picking them out randomly. And so, one possible combination is I pick the red one first, the blue one second, and the green one third. Well, that should be green, but. And then my next possible, well, one of the next possibles is I pick the red one first, then the green one, then the blue one. I keep hitting my color change here and it's not going on me. There we go. There we go. Well, that's all the possibilities I can get with red, so maybe I pick my RBG. I'll do blue, then green, then red. Or I could do blue, then red, then green, then green. There we go. And that's all the possible blues I can do, but I could pick green first, and then in red, and then in blue. Or I could pick green first, and then blue, then red. Sorry if you hear my hands shuffling on. And that's all the possible combinations I can do. And there's 1, 2, 3, 4, 5, 6. Well, there's a way of thinking about this mathematically, and it's going to invent a new multiplication for us. When I go to pick out of the bucket, I have 3 possibilities I can get. Now, once I've picked that first one, whichever one it is, there's only 2 more things left in the bucket. And so for each one of these 3, I have 2 more options. So I have 3 times 2. And then once I pick that second one, there's only 1 option left. And so I have 1. And so I can multiply 3 times 2 times 1. And that gives me the 6 patterns I would see. And we're going to have to count things like that, where the options come out. And so they invented a way of talking about this type of multiplication. It has a pattern. However many things I have, times 1 less, times 1 less. And that pattern's called a factorial. And we write it by saying 3, and we give it the factorial symbol, which is an exclamation point. And that means 3 times 2 times 1. Now there's a couple special things we have to do, and because it's talking about how many ways I can choose 3 things, we'll make this definition work for us, but we kind of have to have an idea of what happens when I say 0 factorial. And that answer is 1. And think of it this way. How many ways do I have to pick nothing? I've only got 1. I've got nothing. There it is. I picked it. That's my 1 nothing. And the same thing is if I have 1 thing, how many ways do I have to pick 1 thing? Well, it's only 1. And so kind of have to realize when I get these smaller things on the end, 0 factorial is 1, 1 factorial is 1, 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, 4 factorial is 4 times 3 times 2 times 1. And one of the things we're going to see in what we're moving into is we get large numbers really quickly. And factorials is one of the ways we do that. Now, we can do different operations with factorials. We'll have to sometimes divine factorials. And also sometimes we have to add or subtract things that make up a factorial. A common thing we'll see is we'll have some number of things minus things that were taken out of the choice. And so we'll get n minus r factorial. And so if n is 6 and r is 2, then we put 6 in here and 2 in here, and we do the parentheses first, and we get 4 factorial, or 4 times 3 times 2 times 1, or 24. And so this is a type of mathematics we'll see. These numbers get big really quick. So just using my calculator's factorial key, which I'm going to see if I can switch over to it here without breaking anything this time around. This is my 5th attempt at this is my 2nd attempt at this video, because my factorial broke the video and it just stopped all of a sudden. But let's go over here and see if I can pull up my calculator. And so I'm going to pull up the calculator and I'm going to turn it on, clear what was on it, and I'm going to just pick a number. I think I'm going to pick 24. And I'll see if I break it already. And I'm going to go in and I am going to choose the factorial key. Now, factorial is in the TI-84s and all the probability stuff, which I believe is in stats. Oh, I always forget these special keys. Let me quit. So 24. On my TI-30, the really cheap calculator, it's easily visible under the probability key. If I go to math, there we go. I'll go to math, over to probability, and I'll come down and I have a factorial key. That's what it was. I had to figure out where my probability key was. You do realize I have 6 different calculators I have to explain to people, and some of the menus are slightly different. So if you ever see me lost in here, just laugh. Well, that's a really huge number. This is 6.20448417 times 10 to the 23rd. So let me come back over here and we'll talk about this number. So let me moving some things around here. So the number we got out from 24 factorial, and 24 is not a large, 24 things has 6.2044844017 times 10 to the 23rd. And so if I were to write this number, and this is an approximation, the calculator actually had a round somewhere in for this because it's such a big number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I think I got that right. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yep. And so that's what this number is, 6.204 times 10 to the 23rd. So let me put my commas in here, and I'll try to say this number. I might not be able to say it. I had a phone bill like this once, but we'll talk about that later. Oh, this isn't too bad. This is 620 sextillion, 448 quintillion, 401 quadrillion, 700 trillion. So 626 trillion, 448 quadrillion, 401 or quintillion, 401 quadrillion, 700 trillion. It's a big number. And that's how many choices I have if I only have 24 things. And so our numbers grow rather quickly here. We'll definitely need our technology sometimes to spit out answers, but we sometimes are going to need another tool. And one of the things we'll see often is we'll get some number factorial divided by some other number factorial. usually in an n minus r factorial form. And so what ends up happening is you get something like, I'll use 24 factorial because we knew it was really, really huge, but underneath it I'm going to divide by 22 factorial. So I'm going to have this really huge number upstairs and this really huge number downstairs. And so they're actually, I take something really, really big and divide it by something else really, really big, and they come out with an ordinary number. Look at 500 million divided by 200 million. Right? Really, really big number divided by another really, really big number ends up being 5 halves. And the same thing's kind of going on here. We have some really, 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 really big number being divided by another really, really big number. Well, a way to help it is really not to run to the calculator or to try to multiply the top then multiply the bottom, but hide in what the factorial means. And so it's this collection of multiplications. So I'm doing the upstairs in my fraction here. 14 times 13 times 12 times 11 times 10, all the way down to 1. Right? So it's a series of multiplications. But downstairs, on the bottom of the fraction, I have 22 times 21 times 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10, all the way down to 1. And so we get this top and bottom that kind of complement each other. But notice 22 over 22, well, that's 1. 21 over 21, that's 1. 20 over 20, that's 1. 19 over 19. And all of these bits over here line up, leaving me only with 24 over 20, 24 times 23 in the front. And so you can kind of think of the smaller number goes away, becomes 1 downstairs, and leaves only the multiplications above it, which is 23 and 24. And I still run to my calculator for that, but that's 552. That's so much better than this big number divided by whatever that big number underneath it's going to be. And so when you're dealing with factorials, you'll use your technology to help you out. And we'll find other ways of calculating things like this, but sometimes you're going to need to stop and just don't type it in, but think about what it means underneath the hood and cancel out the similar things. So give another example here. Like I said, I have the worksheets up there. You can practice on the worksheet. If I have 15 factorial upstairs and 17 factorial downstairs, well, I know this is the smaller number. So it's going to go away to 1, and it's only going to leave the multiplications above it, which are 16 and 17. And so I get 1, and now I can run to my calculator because it's not so bad. I get 1 over 272. And so play with factorials if this is your first time seeing them. Work on the worksheet, and if you have any questions, holler, okay? Now, if I can find the stop button, I'll stop this and I'll post it online for you guys. Cheerio.